In this video, we're going to go over a common problem in projectile motion where we have a daredevil that rides his motorcycle off a cliff to get to the other side of a canyon. So go ahead and read the problem. So a daredevil wants to ride his motorcycle off a cliff next to a 90-meter canyon and land on the ground on the other side, which is 32 meters below the cliff. What is the minimum initial velocity needed to make it across the canyon, and what would the magnitude and the angle of the final velocity be if he's going at the minimum initial velocity at the beginning? So first of all, let's just draw a picture and figure out what we know and what we need to know. So this is our cliff here, and he wants to get to the other side. So in the middle, there can be water or just a fall. Doesn't really matter. We know he wants to get to this other side. We also know that this canyon is 90 meters in length. So this length here, the length he needs to jump over is delta x, and that is 90 meters. And then we're also told that the other side of the canyon is 32 meters below the cliff that he's jumping off on. So this distance here, or change in our y direction, so delta y is actually going to be negative 32 meters since he's going downward. So we know our change in position and the x and y coordinates. And we need to know the minimum initial velocity. So we know that he's riding this motorcycle off of this cliff. This is our v initial. And what can we say about this initial velocity? Well, he's driving off of a cliff, so this is a horizontal velocity. There's no y component initially, so this is v initial x, and then we know that v initial y is 0 meters per second. Now he is going to gain some velocity as soon as he makes it off of the cliff, because there's, of course, acceleration due to gravity, and that's going to start accelerating him downward. So our trajectory is going to look like this if we just make it across this canyon. Let's look at our equations. We know delta y, so that's delta y equals v initial y times the time plus 1/2 times the acceleration times t squared. And then our delta x is going to be v initial x times the time. And there's no acceleration in the x direction in projectile motion problems, so our delta x is just equal to v initial x times t. And we want to find v initial x, so what we're going to need, if we just divide both sides by t, we just need to find this time, and we can use what we know in the y direction to find that time and then apply it to this equation here. So using this first equation, we already said that we know v initial y is 0, and that's going to make this just equal to 1/2 a, which is g t squared. And then so delta y equals 1/2 gt squared, then solving for t, we're going to get t equals 2 times delta y divided by g and take the square root, right? So we just multiplied both sides by 2, divided by g, and took the square root to get the t by itself. Now we can plug in the values that we have here. So t, our time, is equal to the square root of 2 times delta y. Now delta y was negative, so that's negative 32 meters, divided by g, which of course is also negative 9.8 meters per second squared. So these negatives cancel out, and we'll get a positive number, which is what we need for time. So this is going to give us 2.56 seconds. Now we can just plug this back into the equation for v initial x. V initial x equals delta x, which is 90 meters, divided by the time, 2.56 2.56 seconds. I just kept an extra significant figure on that, but we're going to round it to 2 significant figures at the end. So plugging this into a calculator, we're going to end up with 35 meters per second. So this Daredevil needs to be going at least 35 meters per second if he wants to make it across the cliff alive. And now we want to know if he's going at this velocity, what would the magnitude and the angle of the final velocity be? So our final velocity, so if we look at the final velocity vector, that's going to be right here, landing on the cliff. This is v final, and it's going to have both an x and y component. And the angle is going to be a negative angle from the x-axis, this angle right here. So this is what we want to find. So our x component, we know was initially 35 meters per second. If we look at our kinematic equations, right here, we can try to find an equation where we can find our final velocities. So this one here and this one here have a final velocity. And we could really use either of these, but we'll go ahead and use v final equals v initial plus a t. And you can see right away, since we don't have acceleration in the x direction, our v final x is actually equal to v initial x. No acceleration, so the velocity stays the same. And for v final y, in this case, we didn't have an initial velocity, so that term is 0. So v final y is going to equal negative 9.8 meters per second squared. So that's our acceleration, negative 9.8, so that's g, times the time, which we know to be 2.56 seconds. And that gives us negative 25 meters per second for our final velocity. So now we have our x and y component of the velocity. We can just use some trig to find the magnitude. So our velocity vector looked like this. We have our x and y components, v final x and v final y. So all we need to do is use the Pythagorean theorem to find the magnitude, which is the hypotenuse of this triangle. So the magnitude of v final is just going to be the square root of v initial x squared plus v final x squared plus v final y squared. And that is going to be the square root of our initial velocity, which was 35 meters per second. We square that plus negative 25 meters per second. The negative sign won't matter because we're squaring it. And this is going to give us a magnitude of 43 meters per second. So this is the magnitude of the final velocity. Now, if we want to find the angle, again, we're just using trig. So we're looking for this angle here. So the x-axis would be up here. So that's going to be equal to this angle. All we have to do is use tangent of theta is equal to v f y over v f x. And then solving for the angle, that's theta equals the inverse tangent of vfy, which is negative 25 over 35. Meters per second units cancel out. And that's going to give us an angle of negative 36 degrees. So this is our magnitude and angle of the final velocity. That's given up here. So hopefully that was helpful. This kind of problem is basically the same as a ball rolling off of the table problem. You have an initial velocity in the x direction, and it lands somewhere further away. You're just not trying to land, over a canyon. You happen to land on the floor. So if you see those kinds of problems with like a cart or ball or something rolling off of a table at some initial velocity, it's going to work the same way as this kind of problem as well. So hopefully that was helpful, and let me know if there's anything else you guys would like to see.